This is an interesting problem, one in which it might be helpful to draw a picture so you can understand what's going on. The areas of two circles are 15 square centimeters and 20 square centimeters. And they want us to find the exact ratio of the radius of the smaller circle to the larger circle. So let's draw our circles. So there's one circle, not a very good circle, but it's a circle nonetheless, and another circle. So I know that this area is equal to 15 square centimeters. So I'm going to call this the area S for smaller circle. And the area of this circle is 20 square centimeters, and I'm going to call this one AL for large. Now I know in my circles I have a radius, so I'm going to draw that in. And this is going to be my radius sub S for small, and my radius sub L for large. So they haven't given me the equation for the area of a circle. That's something that's assumed that you already know. Look it up. So the area of a circle is pi r squared. Okay. So they want us to find the ratio of each radii, the radius of the smaller to the larger. So what are we looking for? We're looking for the ratio of the smaller to the ratio of the larger. That's what we want right there, that ratio. We could write it like that, or we could write it like this. Either way would work, but that's what we're looking for our answer. So what does that mean I need to do? It means I need to solve for this radius and this radius. So let's do this one first. So my area is 15 centimeters squared, which equals pi r squared. So how do I solve for that? Well, this pi is being multiplied to that r. So I'm going to divide both sides by pi. I'm going to leave this in pi form. So this is 15 over pi centimeters squared is equal to my radius squared. So to undo my radius, I have to take the square root of both sides. I am not going to put plus or minus here because distance is always positive. So that means here, that gives me the square root of 15 over the square root of pi centimeters, which equals my radius. Okay, so the problem is now I've got this radical in the denominator, and I should rationalize that. So in order to get rid of a square root, I'm going to multiply it by itself. So if I have the square root of 15 over the square root of pi, I'm going to multiply that by my number 1, but my number 1 looks like a fraction. In order to undo a square root, I have to do it twice. So whatever I put in the bottom, I also put in the top. Okay? And I can bring down my centimeters and my radius because that's what I'm solving for. So that means this in the denominator just becomes pi. And because both of these are the same radical, it's a square root, that's the same as the square root of 15 times pi, so I'm just going to keep that 15 pi. centimeters, and that's equal to my radius short. Okay, so when I go back up here, I'm going to use this one right here. My radius short is in the top, so it's the square root of 15 pi divided by pi all over, I've got to find my other radius. So that means I'm going to do the whole thing all over again for this circle. So this is going to be 20 centimeters squared is equal to pi r squared. Divide both sides by pi. So that gives me 20 over pi centimeters squared is equal to r squared. I'm going to take the square root of both sides so I can release that r from being squared. So that gives me the square root of 20 over the square root of pi centimeters is equal to my radius. So this is my radius long. I should be putting an L there for radius long. And this here was radius short or small. Okay, so I'm going to do the same thing here. Square root of 20 over square root of pi times my magic number 1, which is the square root of pi over the square root of pi. Just copy down the centimeters and my radius. So that means that I have the square root of 20 pi over pi centimeters. That's my radius for my larger circle. Not done. This one's a little different because the square root of 20, I have a factor that's a perfect square, unlike the square root of 15, or I don't. So the square root of 20, that's the same as the square root of 4 times 5, and I have my pi there also. So the square root of 4 is 2. Square root of 5 is just the square root of 5, and a square root of pi is just the square root of pi. So that's the radius of my larger circle. So I'm going to put this in the denominator of my other fraction. 2 square root of 5 pi over pi. So now I have to clean this up. So to clean this up, that's going to be the square root of 15 pi over pi times, I'm going to take the reciprocal of this, pi over 2 square root of 5 pi. My pi's cancel out. I have the square root of 15 pi over 2 square root of 5 pi. But remember, I cannot have a radical in the denominator. So I have to multiply this by my magic number 1. I want to get rid of this square root of 5 pi. So I multiply it by the square root of 5 pi in both the numerator and the denominator. So that gives me 5 times 15. I'm intentionally not going to multiply that out. I'm going to show you why in a minute. It's going to save me a step. And that's pi times pi. And then in the denominator, I have 2 times 5 pi. So when I have a square root, this is saying look for 2 of the same and take it out. So that means that this is 3 times 5, which is my 15, times 5, times pi, all over 10 pi, because that's 2 times 5 pi is 10 pi. I'm looking for 2 of the same. That makes one group. That makes another group. So what do I have in this set? Comes out as a 5. Times, what do I have in this set? A pi. That comes out. What do I have left? The square root of 3. What's in my denominator? 10 divided by pi. Pi divided by pi is 1. 5 goes into 5 one time. 5 goes into 10 two times. So my final answer is it's a ratio of the square root of 3 to 2. That's my ratio of small to large.